In this lab, I analyzed a moving object and applied Newton's second law. I took a video of a ball rolling across the carpet, analyzed the video using tracker software, plotted the position versus time, and created a model in PHYS. In this video, I will discuss how Newton's second law explains the motion of the ball. I used Tracker to collect the observed or experimental data. To do this, I estimated the average position of the ball for each frame, setting the axes so that the ball's velocity is in the positive x direction and the y component is nearly zero. This saves some work, because if I instead chose my axes perpendicular to the frame of video, I would need to consider the y component of the ball's velocity as well. Tracker now provides time and position data for each frame. There will be some error in the observed data because I could not hold the camera perfectly still and because the ball did not roll in a straight line, as seen in this y position graph. Next, I used PHYS to collect the predicted or theoretical data. To do this, I calculated the average velocity of the ball using the total time and distance traveled. I created a model in PHYS. A ball rolls across the screen and its position is given for each iteration. Predicted data and observed data can be compared in a graph of position versus time. The graph shows how the model's constant velocity compares to the real ball's velocity. Newton's second law states that in the case of zero net force, an object will continue at the same speed. If the net force on the ball is zero, it will move at a constant velocity. This is the case in the model, where F net is set to zero. We cannot say for sure how many forces are in play, only that they all add up to zero. From the graph we can see that the ball's velocity is nearly constant but not quite, so some small net force is present.